Welcome to Desk of Ladyada.
Hey everybody, and welcome to Desk of Ladyada. It's Sunday night at 8 o'clock, hacker time. So it's time to see what's going on my desk. I did a little bit of engineering, hacking, and a little traveling this week. First up, we went and visited some cherry trees, and we got some photos featuring a KB2040 I thought would be fun to share.
It was a celebration of spring.
And pink PCBs.
You know, nature and electronics and art are all connected, and it's beautiful that there's colors in nature and colors in the things that we do. And these are some of the photos I took. Bird. And it was great to get outside and soak up some energy from the sun, and then use that energy to make cool electronics and more. So we'll have a very fun giveaway special thing coming up soon. But that's one of the ways that we celebrated this beautiful spring weekend.
True. Okay. Yes, we've got the pink KB2040, which is in this pink floppy disk. We're getting back to some floppy stuff soon. We've been so busy with dealing with chip shortage stuff, but we're always getting parts. So one thing I did this week is I got some chip samples of the CH9102F. We did a little 1-minute video that Mr. Ladyada will probably post up this week, but I can also show it to you here. So this chip is from WCH, and they make a very popular low-cost USB serial converter called the CH340 or 430, and you've seen it on ESP32 boards for sure. So this is the chip here. And what's interesting about this, the CH9102 is it is the same pinout and like pin configuration as the SI 2104 and 2102N, which we use a lot in our boards. We really like that chip. And we have some CP2102/04s on order, but right now the way things work is a lot of chips are on allocation. And what that means is that we've booked them, and we book them at a price that makes it possible for us to sell our goods made in the U.S. To you and have it be a good price. But we're not getting our allocation for a bit. And so I'm going to ask to get the allocation moved up a little bit so I can get some more boards on, because we actually came up with a lot of very popular boards lately that use the CP2102N, and we kind of went through our, we had a couple months worth, and then we kind of went through it very quickly. But this chip is a QFN, I think it's 2428. There is one thing about it that I got to figure out, which is it does have support for the RX and TX LEDs, which I really like about the CP2102 and 2104. I have some code for the Scilabs chips to connect over, USB with Pi USB, and connect to the chip and basically enable right to the EEPROM and enable the RX and TX LEDs, because they're not enabled by default. I have to redo that for the CH series because it's not the same EEPROM, it's not the same commands. I found some code in Mandarin that does it, and I have to their code, and it's in like Windows DLL format, whatever. But I think I can parse through it, and maybe I can get this program to run and then use my USB sniffer to watch what commands are going over, and then I'll just redo that code in Python to enable the RX and TX LEDs. Not all of our boards have RX and TX LEDs on the serial, but a few do, like the Metro 328, the Metro Mini, the Bluetooth sniffer and Bluetooth friend, and a couple others. So some boards don't use it, and some boards do. I think it's for some beginner boards like the Metro. I think it's handy, but for like the ESP32 Feather, I don't expose the LEDs because I figure it's like there's enough going on this board, and usually the USB serial part isn't the issue. So if you look really carefully, although I don't think it's going to be able to pick it up, I hot aired the, you can barely see it says WCH here. So I hot aired the CP2102N that was on here, put this one on, and you do need to get new drivers, but it worked fine. So, I only have like 20 pieces sample, and I'm definitely going to go through these because as I'm learning this EEPROM thing, I the first one I plugged in, and I promptly completely destroyed the EEPROM, and it came up with like VID FFFF, and I'm like, the driver doesn't work anymore. So, because I was like clicking on this program and just messing around. So I'm going to have to do that a couple more times and hopefully figure out how to get that RX and TX LED enabled. Because that's like the only thing that I need to do. And then for Mac M1, Mr. Ladyada has an M1 Mac, and so I was able to test it, and we did get it working. You do have to install a separate driver. Again, it's not, it's not the built-in USB-C DC. It's a unique driver. So, not a big deal. I've noticed M5 Stack, also moved to this chip. I think a lot of companies are. Because if you can't get your chips on allocation, that's the same as not being able to get the chips at all, right? It's like, okay, you have them, but you're not sending them to me. How is that any different than me not being able to get them at all? So, whereas WCH, I think, has these available in stock. So you'll probably see that. You'll see some revisions on boards as we change over. There's some boards that you can't really do revisions on because it's like if you can't get the part, you can't get the part. But the USB serial chip, I'm willing to do a lot of work because we have so many popular boards that have USB serial converter chips on them. So that's the WCH9102F. If you're looking for a Scilabs replacement, this seems to work just fine. Just be aware that the RX and TX LED, there isn't like a happy, cute tool like Scilabs has that it works perfectly. It's in Chinese, and I don't have my computer set up in the right way to even. It's like if I could at least look at the characters, I could probably figure out, what it says, but I don't even have the right, whatever Windows mode I have to be in for it to show up properly. I haven't been able to figure that out because it shows up as little boxes. Okay, so that's that. Next up, I also got this fun sample, which I thought was kind of neat. So this is a USB C cable, and if you look carefully, you can see it says 15 volts on it. So this is a cable, and it has like this inside of it or something similar. It's a USB power delivery sync chip, and it connects to those CC1 and CC2 pins that so well from USB-C. You have to usually connect them to a resistor to ground to enable 5 volts of power. So this one, but there's no like other resistors you can use. Like 5 volt is a special case. If you want anything else, you have to actually do PD negotiation. And so this chip is a PD negotiation chip. And what's neat is that like this cable just has like a DC jack on the other end, which is kind of cool because it's like you don't have to do anything with this. This cable's ready to go, and so you can plug this in. I've got here. If you have a proper USB-C adapter, so this is like a fancy Apple adapter, and you can read the text there. It says output 5 volts 3 amps, 9 volt 3 amps, 12 volt 3 amps, 15 volts 3 up 20 volts 3.25 amps. So basically this can provide 5, 9, 12, 15, or 20, which is almost all the voltages. I think 18 is the only voltage that isn't provided here. And the point was that, you could use this adapter to theoretically charge your laptop or, any other Apple device, depending on, like an iPad, I think wants like 9 or 12 volts to fast charge. And your iPhone, I think, wants like 5 volts to fast charge, whatever. Any device you can plug in, and it will automatically get the highest voltage possible, which will increase the charging speed. So when you plug this funky cable in, and I plug it into my desktop power, and then I've got my multimeter here, it comes out with 15 volts. oops, 15 volts, just as expected. And I put this on my load meter. I have a load meter that can, plug in. You power this, connect to the load meter, and the load meter you can dial in how much current you want to draw, and then you look at the voltage to see like, hey, at 3 amps, it gives you 3 amps, 15 volts. So this is a nice little cable. I thought this would be really handy if you don't want to like mess around with PD. It's like kind of auto PD-ification. And then this chip I got here. So I also got like, the cable without the cable, because I was kind of like curious about this chip. And if you can read the text, it's quite small. I don't think it'll show up here. Yeah, it's too tiny. But it says HUSB 238. So you can go to the computer and I'll show I looked that up. So this is a Type-C power delivery sync controller. It's made by, one of these, I think it's an Asian silicon company. They don't make a lot of stuff, but they make a couple different chips for the Asian market. But this chip is actually kind of nice because VSET and iSet, the thing that sets the voltage and the current request, is set by a resistor, and there's also I2C, so you can kind of do either. I don't know whether the I2C is persistent or whether it's like dynamic, but it's a very easy kit to set up. You just connect it up to the D plus, D minus, and CC lines. You have a little gate transistor here if you'd like, so you can make sure it doesn't turn on until it's ready. And then you just set the voltage and the current with resistors, and then they give you the resistor kit at the bottom. And like the documentation is actually pretty good. So they tell you like, you set the resistor to this kilo ohm, and this is what the voltage. It'll try to get you that voltage, or at no higher than that, but it'll try to get you that voltage. So I made a quick breakout design with this, with like all the resistors, and then you can short them to select which one you want, and then you can select the current you want as well. And then at the bottom there's a breakout, or you can use like these big pads. This is the chip, and this is the pass transistor, although it's a little unclear to me whether you need the pass transistor, but I think it's a good taste, so I figured I'd leave it in there. So this is a USB-C to power delivery sync, and I've tried other chips, like there's the IP2721. Didn't really like it so much. It was like, it did some voltage and not others, and I also like I would plug it in, it would pop. So I made a breakout for the IP2721. I didn't dig it. There's also the ST USB 4500 from ST, and that's like a very fancy programmable PD sync, but it's like totally unavailable right now. And I don't know when. It's like 98-week lead time, so forget it. Unavailable. I'm hoping I can probably get this chip and I can make some of these breakouts, because I think a lot of people want to have a little board where you plug it into like one of these nice power adapters. You can get any voltage you want or need for your design. So I thought this little breakout would be pretty cute. Okay, so that's what I've been working on. Any questions before we move on?
I answered the ones in the chat. You want to do some great search?
Yeah, I thought we'd pop into the great search.
Here we go.
Where in the world is that part I need? The great search with DigiKey.
The great search brought to you by Adafruit and DigiKey. Ladyada user powers of engineering to show you where to find and how to find the part that you're looking for on digikey.com. Ladyada, what is a great search this week?
Okay, well, let's go to the overhead. So this week, can you show the photos? We went to
Which one?
the Botanical Gardens, and we celebrated pink, and we thought we would take some photos with our nice pink PCB. I love to show these photos again. And this inspired me today, because you were asking, like, we have these pink PCBs on the overhead. This is the pink KB2040 PCB with the custom pink solder mask from our PCB house we use. I know PCB Way will do prototypes. One second. You can do it. Okay. You can get prototypes from PCB Way, but our PCB house, we got these custom pink PCBs. And you were like, can we change this green LED to be like pink or purple? Because it would look a lot better than just green, right? If you wanted to go with the pink aesthetic. which we do love here at Adafruit. And I thought I'll also get an excuse to show how to get, like weird colored LEDs on DigiKey. And also a lot of people are always like, oh, there's so many LEDs on DigiKey, and it's like, I just want to like get it to a reasonable amount and then I can pick the color. And then how to use the nanometer selector also to determine what color you're going to get. So even though I didn't end up finding pink exactly, I did find something very close. So let's go to the computer. And let's go to DigiKey. Okay, so what we're looking for is an indicator LED. There's illumination LEDs, and those are like really bright, like white LEDs for backlights. Indicators are like what you saw on that PCB. It's a little light, usually a 402 to 1206 size. 20 to maybe 200 millicandela, just enough to indicate to a person that something is working or not working. So we want discrete, which means individual, because there's ones that are in arrays, and there's one that are like pilot light, like panel indicators. We want individual ones. And then I'm just going to show you how to pare it down, because I particularly want pink, but I ended up not being able to find pink. So it's like, what was the closest thing I could get? So there's a lot of LEDs, and I know it can be very tough to find LEDs. So the first thing I'll do is I'm just going to look only for the active ones. It's a quick way of paring down about half of them, because we don't want ones that are discontinued or unavailable. There's also the configuration. So there's some of these are dual color, like they're red and green, and you can turn on both to make them amber. So they're bidirectional, or they have common anode or common cathode. If you see common anode or common cathode, that means it has to have more than one LED in it. Otherwise, there wouldn't be a common to it. So what we want is independent, standard, and dash, which means like, okay, it didn't get categorized with that. So that'll maybe get rid of a couple thousand more, because we only want like an individual LED. The next thing we're going to look at is I only want surface mount, and I only want surface mount pointing up. So I'm going to just make sure that I've deselected all the through-hole ones, and that'll cut it down by half again. So you see, you're cutting it down by half to get to where you could actually pick parts. Because now, if you look, we're actually getting little surface mount LEDs. So it's a lot closer. So the next thing is that they do have color, and so you can pick out color here. Another thing you can do, because I'll note that some of these are a little they're a little annoying, because you're like, well, what is green yellow versus green? Like green and green, for example, green can mean two different things in LEDs. It can be like a yellowish green, which is, let me try to remember I don't know if they have the chemistry behind them, but there's like the INGAN and the IMP. I don't think they have the chemistry here. Oh, interesting. They don't. Yep, they don't show you. But basically the chemistry by which they make the LED determines the color of the LED. So some interesting colors, like pink particularly, there's no such real thing as a pink LED. Usually it's a white LED that's painted over with like a pink paint. And so the white shines through the pink and kind of lights up pink. It's like a painted light bulb. So what you might want to do is, see here, the lens color, is you might want to look at the wavelength peak or the dominant wavelength, either one. Actually, I'm going to deselect independent, because I think I'm seeing that there's RGB LEDs here. So let me go back to this, and I'm just going to click standard, because I don't want the multi LEDs. Okay, let me get a couple few. So, blue, what does like blue mean versus like ice blue? This is where you might want to search by the wavelength. So, let's see, you can search for like nanometer, wavelength, maybe color. There's a whole bunch of, there's like these diagrams. that'll show you the nanometer wavelength. So if you're looking for something reddish, it's going to be 740. And if you're looking for something like light yellowish, you're going to be like, actually, this isn't a very good diagram. Hold on. Let me find a better diagram. Ooh, this is a better diagram. Okay. Yeah, so this is, if you want something yellow greenish, it's going to be maybe like 570, but if you want like a deep greenish, it's going to be 525. So let's look at, for example, like ice blue. It's probably going to be like 470 or something, maybe 475. So let's go back here, because I was actually kind of curious about this ice blue color. Where was I? There you go. Ice blue. So let's see what comes up when we search for ice blue. Wow, there's like one. So this is a discrete ice blue LED. It does look like it's a white LED with like maybe a phosphor on top of it. And it doesn't have the dominant wavelength. Sometimes they don't, especially if it's because it's a white LED and it's covered with a fluorescent, so it's actually not a true single color. So let's actually look for like a purple. So purple or pink LED is going to be more towards, more towards like at the end here. So maybe like 425. You can see here it's like 435 or something. So let's look at, let's go back. And look at the filters, and let's look at, there are so many options. Hold on, there you go. Pink and purple. Let's see what comes up. So yeah, there weren't a lot of options for pink and purple, and the pink they do have, but it's unfortunately in this large package, which is not for me. I mean, like, this will be a really beautiful pink LED because it's going to have like this nice phosphored. It looks like it's probably a blue LED with a pink orangish phosphor on top, and the color mixes. So yeah, this one also won't have a dominant wavelength or peak because it's actually a mix of colors. However, this purple LED actually looked pretty nice, and it's fairly inexpensive. It's a marketplace, so it's from another vendor. But this one does have, it's a single emitter LED. So this purple LED is a true like single wavelength color LED. So you're going to get 420 nanometers, which is, over here past blue, or on this one, it's over here purple. And don't forget to also check the data sheet, because the data sheet could also have some really good info. For example, it tells you, also just verify the wavelength. It also might tell you whether it's the material, so in Gen N, so it's like they just pushed that blue, what would normally be a blue LED, all the way into purple just by doping it. And then the lens is water clear. That means that the light itself is purple, not white painted over, because that would be a different lens color. That would be like I think they would just call it like a milky white lens. Let's see what they call the pink one. Let's look at this data sheet, which I didn't look at, so I'm curious. This one, they say is pink in Gen N. Yeah, so this one, it's like they tell you the chromatity because I guess it's covered, but they don't tell you what it is originally. Oh, interesting, it's even binned. These are nice LEDs. So for this one, it does again, you don't get a wavelength because it's a white painted cover. It's not a clear lens. So in the end, I was like, wow, this is gonna have a cool logo. Did you check out this logo?
That's cool.
That's Venkel. I wasn't expecting that.
This is like a company that Johnny Mnemonic gets his computers from.
That is very futuristic.
I know, that's cool.
Somebody definitely went to art.
Venkel, never change, please. Please
Never
keep
change.
that. Yeah, do not rebrand.
Don't get normal.
Do not rebrand.
Keep it weird. Okay, so So I actually really like this one because I actually kind of like the idea of like a pure purple light coming from this 0603 LED. So I think I'm actually going to go, even though this one's pink, for it to work on my PCB because I need it to be 0603, I'm going to go with this one, the CTL 0603 FPU. So I'm actually going to try to get a couple samples of this, put it on the pink PCB and see how it looks. It might look really good.
And that is Great Church.
Where in the world is that part I need? The great search with DigiKey.
Okay, question that came in. Folks
Yes.
really like, pink PCBs, of course. Is it possible to get pink headers?
We do have some red headers. You can get custom pink. I'll tell you the thing, you can get custom anything, but you have to buy a lot. Although
Yeah.
maybe I should get pink headers. What do you think, Phil?
Well, we're getting pink JSTs, so yeah, let's try.
Yeah, I can.
Yeah.
I can probably look for a pink. The thing is, what pink exactly? 'Cause there's a couple different pinks. I think a light pink could be nice.
Yeah. Okay, let me see if there's anything else here.
Problem is that then you have to be careful soldering them because that's the way you could brown them a little bit.
Okay. Oh, someone wanted to hear the chip shortage song. So
Okay.
every Wednesday we have this new segment. Last week we did microchip, the chips that we need. It was like the SAMD51Js or something like
Yeah,
that.
good.
And then before
yeah,
that,
you're memorizing all the parts.
that's right.
Go get them for me.
Yeah. And then the week before that was Bosch sensor. So here's the song
Here's the jingle.
that when you're doing your engineering work and
Or
you're
in the
like,
shower.
and I can't get that part, you can sing along, and this is a song.
Sing along with the
Chip shortage. It's the chip shortage. Every day. In every way. It's the chip shortage. It's the chip shortage. Every day. In every way.
So yeah, we have a new one coming up this Wednesday on Ask an Engineer.
There's no shortage of
There's no
chips.
shortage of shortages.
There's shortage, yeah.
Yeah. So that's our show on
Okay.
Desk of Ladyada for this week. Thank you everyone for joining us and spending some of your Sunday with us. We know you have lots of choices and other things you can do and more. We very much appreciate you and being here.
Is there a show shortage?
There's not a show shortage yet. But the time that we have, we try to do the best we can with what we have, including the parts we have, the time we have, and all the things that we can do together. So we'll see everybody during the week. We got lots of fun stuff. Every single day this week there's something going to be super fun. We're posting up on all the different social media places, our blog, and more. So tune in. We'll see everybody next week. Bye, everybody.
Bye, everybody.